Alright, hey. Alright, pre-calc, I don't really have a video on this inverse trigonometric functions stuff. I looked, so I'm going to make one, but it's going to be not my best video. I'm going to try to go kind of quickly, but I wanted to give you something in case you were preparing for tomorrow's quiz. I want to give you something to watch. Who's that? That's my dog, in case you guys haven't met him yet. That's him. But okay, who cares? Let's do the video. So I'm going to run through the packet, but I'm going to run through only what kind of matters, and I'm not going to talk about this stuff. We kind of went through all this already, but this was sort of trying to set the stage for why we restricted the domains of each trig function to what we restricted them to. So, I don't know, you remember, don't you, that our criterion for choosing a well-restricted domain was, in that domain we wanted to be 1 to 1. And then we also wanted to have the same range as the unrestricted function. And what else did we want? Let's call it proximity to 0. Alright, and again, I don't know why I'm saying it like that, but basically, when we had to make a choice about where we wanted to slice, well, we literally always sliced either to the left and right of 0, choosing an interval that went from negative 90 to 90, or really negative pi over 2 to pi over 2, or we made the choice to slice starting from 0. So we'd start right on 0 and choose the next 180 degrees or pi radians. But what you're looking at is literally every single restricted domain that we used. The ones that seem more complicated, they're not really more complicated. It's just, for domain and range. I mean, for like the sine function, we went from negative pi over 2 to pi over 2, and we included the ends. For tangent, we went from negative pi over 2 to pi over 2, but we did not include the ends because they were asymptotes. And then, who's the reciprocal of sine? Is it cosecant? Then for cosecant, we went from negative pi over 2 to pi over 2. But we had to poke a hole at 0 because there was an asymptote there. I think I'm saying that right. I mean, I think that's what we did, right? But we always were just using that same interval. It's just, were the ends included or not included, or was there a hole in the middle? And that same idea carried through to the other one too. For cosine, we went ahead and went from 0 all the way to pi, including the ends. But for cotangent, we went from 0 to pi, not including the ends, because those were asymptotes. And for the reciprocal of cosine, which is secant, we went from 0 to pi, poking a hole at pi over 2. I think that's right to say. I believe that's all true. All right. You really don't need to know these graphs for tomorrow's quiz. Now, for the test that we take the following, I feel like it's Wednesday, but I think we're almost certainly pushing it back because Wednesday is not a half day, but it's a 1 Whitman day and would lose like 5 minutes. And we want you to have a full 45 minutes, so I think we're going to push it back to Thursday. Ugh, just get to the point, Mr. F. The point is, you don't need to know the shape. We spent a whole day talking about how this thing was increasing and concave up, and then it was concave. You just don't need to know any of it. You just need to know that if you're trying to evaluate an inverse sine expression, such as the inverse sine of 1/2, and negative 1/2 is the more interesting question, then where do we equal negative 1/2? Well, the unrestricted function equals negative 1/2 in a whole mess of places, like here and here, but also here and here. But you can see by this highlighted bit that the only acceptable answer is that answer right there, right? The one that lives between negative pi over 2 and pi over 2. So the only spot on the unit circle where we really get negative 1/2, it's not at 330 degrees, although kind of is right there. Is that guy 330? Probably that guy's 330, right? That's 330. That's technically yielding the correct value but we only want that guy there. And that guy there is this clockwise rotation of 30 degrees. That's negative pi over 6. And that's the only correct answer, because we limited our domain so that this inverse function would be a function, meaning I don't have to accept negative pi over 6 and also 7 pi over 6 and also 11 pi over 6. This is the only acceptable answer. Moving on. All right, don't care, 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 do care. So these are the quote-unquote basic inverse trigonometric expressions. And so I'd like to think you guys can solve all those just fine, but I could be wrong. So I'll try to explain them again, or will I? Maybe I'll kind of jump ahead. We've done all of these. I'll just change them a smidge. How about that? So if I wanted the inverse sine of a half, then your thought process should go something like this. Your thought process should probably start by saying, if it's inverse sine, then you're thinking about a y value, and you're thinking of how 1/2 is your y value. But you know the answer that you want to give me is an angle. So what are you looking for? You're looking for the angle whose y value is 1/2. 1/2 would be, of the 3 unit circle values, it would be the low one, right? So what angle is rotating us into a position on the unit circle where our y value is positive 1/2? And there's only 2 choices. It's 30-degree reference angle living in quadrant 1 or quadrant 2. But we know that for sine, we restricted our domain to only go from negative 90 to 90. So this guy's out of the running to be an output of inverse sine. The outputs of inverse sine have to be from negative 90 to 90. And the only angle that fits that bill is 30 degrees. Wait, did I just say 30 degrees? I thought I'd say we're never using degrees again. So you better say pi over 6. Got it? Okay. Let's try a reciprocal function down here where it says secant, inverse secant of negative 2. Well, basically, as I explained in class, you just don't actually evaluate this as secant. You just kind of say, I know that the inverse secant of negative 2 is going to be equal to whatever the inverse cosine of negative 1/2 is. Since secant and cosine are reciprocal functions, they're going to take on the same value at inputs that are reciprocals. So you just take the reciprocal of negative 2 and you evaluate this. Now your thought process is similar to what our thought process was here. Remember we said find the angle whose y value is 1/2? Well, now you're finding the angle whose x coordinate is negative 1/2. And if you draw yourself a unit circle, then the only position where x is negative 1/2, now x would be not that far over. So of these 3 positions, it would be the one that's a little bit left. So it's 60-degree reference angles from quadrants 2 and 3. And we have the good fortune of knowing that literally quadrant 3 is never in the actual range of any of our functions. We only restricted our domains to either quadrant 1 and 4 or 1 and 2. Literally no function will ever map onto an angle that's in quadrant 3. So if your only options are quadrants 2 and 3, go for the one that's in quadrant 2. And that angle, of course, is 2 pi over 3, sorry. 2 pi over 3. So that's the answer. The inverse cosine is 2 pi over 3. I'm getting emails, so I'm just going to pause and see what those are. Hold on. Okay, I'm back. So I think I've done 2 problems. We did a sine, we did a secant. Sounds like we should do a tangent, cotangent one. Let's do this cotangent one. So I'm begging you to just probably memorize which is which. So you should know, I don't know, memorize the tangents, I guess, but what is tangent of 30 versus what is tangent of 60? Figure out which is which and then memorize which is which. So how do you even figure out which is which? Well, probably draw a unit circle. Yoink. And for 30 degrees, that of course is the one that has a big x value and then a small y value. So that one's root 3 over 2 and then 1/2. And tangent's y over x. So if I do 1/2 over root 3 over 2, then I can kill the 2's to get 1 over root 3. And then I rationalize that to get root 3 over 3. So the tangent of 30 is the one that's root 3 over 3. And I explained in class, I think to period 3, but not to period 2, that when I see 2 3's, then I know that's the one that's 30. Because if you do tangent of 60, it's going to be the root 3 over 2 and then the 1/2. Killing the 2's, you just get root 3. So if you have root 3 for tangent, that's only 1 3. So that's the 60 degree one. The one that has 2 3's is the 30 degree one. Is that the best way to memorize it? Nope, definitely not. But maybe it's something. The safest thing in the world to do is to actually figure it out and make sure, really make sure that you're right. But if you could memorize those, that would be great. But hopefully from there you guys know that, of course, for cotangent, it's exactly the reverse. The cotangent of 30 is the root 3. And the cotangent of 60 is the root 3 over 3. So there you go. That kind of answers this whole question, by the way, because, of course, this expression is just saying what is the angle whose cotangent is root 3. And we can see that the angle whose cotangent is root 3 is 30, which is pi over 6. And since pi over 6 is quadrant 1, that's a lock, that's definitely in our interval, because quadrant 1 angles are in all of our intervals, in the same way that quadrant 3 is in none of our intervals. Really, the only thing you have to think about is, do I want an answer from quadrant 2 or from quadrant 4? All right, let's tackle some of these two-steppers. Not these draw a triangle boys, though. Scroll down. I don't know. It'd be nice to do one we didn't already do. And I sure hope this looks okay on your screen. It should. It should look passable. It's not going to look great, but you know what? Let's go ahead and do this one. Who cares? So how do you do these two-steppers? Well, you probably want to just go ahead and evaluate the inner function first. It's inverse tangent of root 3, which I literally just talked about. So isn't the angle whose tangent is root 3 60 degrees? I feel like it is. So I feel like that means this is pi over 3. And you're now being asked to find the cosine of that, right? And cosine is the x coordinate. So where again is pi over 3? Isn't that right here? So isn't the x coordinate of that the short coordinate? So isn't that 1/2? And that's it. Just evaluate the inverse trig expression, then evaluate the normal trig and get some answer. What about the next one? Is it just as simple to do that? Well, it's a little different because this time the inverse trig was on the inside. So we did inverse trig to get an angle. Then we did the cosine of that angle to get an x coordinate technically. This time here, the inverse trig is on the outside. That means your final answer here isn't going to be a coordinate from the unit circle. Your final answer this time is going to be an angle. So you do get different outputs depending on whether you're doing inverse trig on the inside or inverse trig on the outside, right? That's maybe sort of interesting to think about. But what is the final answer here? So I wonder, do these two functions just cancel out and give me back the exact same pi over 4? No, they don't. Let's see what happens. I'm going to be doing the inverse cosecant of the cotangent of pi over 4, which we talked about in class. I like to think that pi over 4 is one of the very easy ones. Pi over 4, for sure, has coordinates of root 2 over 2 and then root 2 over 2, which means if I'm doing the ratio of those, which is what cotangent is, it's x over y, then you're doing root 2 over 2 divided by root 2 over 2, and when you divide a number by itself, you get 1. So you're now doing the cosecant of that, though, which really means that you're doing the inverse sine of the reciprocal, which is still 1, right? But either way, we were talking about a 45-degree angle a second ago, but we're now talking about what position on the unit circle has a y value of 1, which means we're now up here. We're in a completely different spot on the unit circle. We're now talking about a pi over 2 radian angle. So the final answer to this expression is pi over 2. So somehow the initial input of pi over 4 got turned into a 1 and then got turned into a pi over 2. So we started in one position on the unit circle, ended up mapped onto a completely different position on the unit circle. That can happen. It's not weird. It's totally normal. Deal with it. All right. What about this one? I wonder if I could explain something here without losing y'all. Let me try. That's my job after all. Professional explainer. Hey, did you ever notice on the unit circle that at 30 degrees we got root 3 over 2 and then 1/2, and then at 60 degrees we got 1/2 and then root 3 over 2? Did anybody ever notice that both of those angles were sort of symmetric across 45 degrees? One of them came 15 degrees before then, the other one came 15 degrees after then. Do you think that's special and sacred for 30 and 60? Or do you think if I was at like 20 degrees and 70 degrees, would that same sort of reflectional relationship still work? What I mean is, if I knew that the coordinates here were A and then B, were the coordinates here gonna be B and then A? Yeah, they would be. You can literally see it. At least I can. I hope you can. You get that this horizontal distance is the A value, right? Well, by the symmetry of a circle, as far as I went right here would be as far as I'd have to go up here. So this x coordinate would definitely be this y coordinate because there's a symmetry there. The rightiness equals the uppiness because of the way those two positions fit. Man, I probably should have drawn a real circle to help you visualize that, and I apologize that I didn't. But maybe you get it. Yeah, I don't know. Ask me about it tomorrow. Hey, you know what else I noticed? I noticed that the y coordinate here, this little sliver of a y value, see that little sliver? That little sliver translates to our little sliver of an x value here. So to me it makes perfect sense that the b value here as a y becomes a b value here as an x. Alright, why the hell does that matter? I think it matters because didn't you ever notice that the sine of 30 and the cosine of 60 were the same damn thing, right? What's the sine of 30? Sine's the y value, so it's a half. What's the cosine of 60? Oh, it's a half. What a weird coincidence. Or is it not a coincidence at all? Does that actually have everything to do with the symmetry of the unit circle? Does it have everything to do with how sine and cosine are defined? It has everything to do with how sine and cosine are defined. So I guess my point was, I actually know that the sine of 20 is definitely going to be the same as the cosine of 70. And I don't know nothing about what the sine of 20 actually is, but I know that geometrically, sine of 20 is this little sliver of a y value, whatever the hell it is. And the cosine of 70 would be this little sliver of an x value, whatever it is. And those two numbers have to be the same. Right. Right. So at least in quadrant 1, these two numbers add up to 90. 30, 60 add up to 90. 20, 70 add up to 90. The real rule isn't quite that. The real rule is that sine of some angle, well, cosine will always be the same thing at 90 minus that angle. And that continues to hold even outside of quadrant 1. Meaning if you wanted the sine of 150, it would be the same as the cosine of negative 60. Maybe don't quote me on that. Oh, and it scrolled off the grid anyway, or off the screen. Good, maybe I want it off the screen. And maybe I want to shut up. This is super important. Let me explain why right now, if you're actually even still listening to me. But we have to jump way ahead to part 4 where it says challenge problem, because we went ahead and put one of these problems on your quiz. Sorry, we probably shouldn't have, but it's going to be there, so you have to know this. So why is this problem a challenge? What makes this thing a challenge? Well, we gave you 9 pi over 10. Is that a unit circle angle? Nope. So do you have any idea what the sine of 9 pi over 10 is? Nope. But here's what you do know. You do know, God, I hope you know, that 10 pi over 10 would be exactly 180, right? 10 pi over 10 is just pi. So you know where 9 pi over 10 is. You know that it's in quadrant 2. And you know that it has this y value. Well, they're now asking you, what's the inverse sine of this guy's y value? Well, I don't know what this guy's y value is, but let's pretend for a moment that this ordered pair was a comma b. Or if it pleases you, we're to the left, so technically it's negative a comma b, I guess, kinda. Well, that would mean that this sine expression just represents the value called b. And you're now being asked to find the inverse sine of b. Well, b is this vertical distance. Couldn't I map it over to here and get the same vertical distance over here? Aren't I talking about two angles with the same reference angle? So the inverse sine would be this guy, because we have to use the angle from the correct quadrant, right? This angle, 9 pi over 10, is in the wrong quadrant. We need the angle from the right quadrant that has the same y value. So we're using the same, sort of the same kind of symmetry I just talked about. And what is our reference angle, by the way? Well, we're 9 pi over 10, and 10 pi over 10 is the x-axis. So our reference angle is 1 pi over 10. That means this angle is 1 pi over 10. That means this big fat expression has a value of 1 pi over 10. And why does it have that value? Because you're talking about two angles, 9 pi over 10 and 1 pi over 10, represent two positions on the unit circle that have the same y value, which means the sine of one, the inverse sine of the other, basically just maps this angle that's outside of quadrant 1 back onto the appropriate angle that's in quadrant 1. All right, that was confusing. I confused myself, I think. Let's do the next one, since the next one is very, very, very much the same. So you're just given a 15 pi over 8 this time. And so 15 pi over 8 is a rotational angle that whips way the heck around, almost all the way, because 16 pi over 8, that's 2 pi. That would be all the way around. So 15 pi over 8 is literally just 1 pi over 8 shy of a full rotation. And what are we after now? We're after the inverse sine of the sine of 15 pi over 8. Well, sine of 15 pi over 8, again, is this little sliver of a y value, right? And I want the inverse sine of that. So I want the angle that gives me that same y value. Well, the only difference here is, I need a rotation angle that lives between negative 90 and 90. So instead of whipping all the way around counterclockwise, I need to go boop and go clockwise. And we literally just said that if I'm 15 pi over 8, then this little sliver of an angle is 1 pi over 8, negative 1 pi over 8. So what just happened? I think we just said that negative pi over 8 is an angle that's in the right window for inverse sine that has the same y valued output as the sine of 15 pi over 8. Right? God, I don't know if I'm explaining that right, but I hope you guys get it. We should probably do these in degrees, but I don't feel like it. I want to jump ahead to the other thing. The super challenge. Because I think the one on the quiz might actually be a super challenge. Why is this a super challenge? It's a super challenge because the regular challenges were always inverse sine of sine, and then inverse sine of sine, inverse cosine of cosine. They all matched. Down here, they're actually mixing the functions. They're doing inverse cosine of sine, and so that actually kind of brings me back to where I was. I was rapping about this relationship here, about how sine and cosine have this relationship, about how they are equal at angle measures that are 90 degrees, that have that 90-degree relationship. Okay. All right. Let me draw a picture and see if it's worth 1,000 words. So what's happening here? And I gotta end this video because it's getting long and it's getting late. Yoink. All right, again, we would start by evaluating the innermost expression, right? So what is the sine of 10 pi over 9? Well, 10 pi over 9 would, again, it would rotate us 9 pi over 9, and then an extra 1 pi over 9, and it would stick us into quadrant 3. And if there was some arbitrary circle here, then the sine of that angle would be this y value. That green segment I just drew is literally the value of this expression. So how long you want that thing to be? What do you want to call it? You want to call it b again? If this point right here is the ordered pair negative a, negative b, then this thing has a length of b, right? So the sine of this would be negative b. So we now need to do the inverse cosine of negative b. All right, what the hell does that mean? Well, the trickiness here is we just had to find a y value, but now we're talking about x values, and we're talking about inverse cosine. So the meaning of this green expression now is we're hunting for the angle whose x coordinate is the same as the y coordinate of this inner function, which was negative b. So where would that put us, negative b? Well, I would need to draw a stick that is the same length as b, but instead of having it go down, I need to have it go left from the y-axis because I want it to be an x-coordinate. I don't know why I drew it there, because I would want it up here, touching the circle. Oh, for crying out loud. Right there. Go over there, not you. Why? Go over there. All right. Oh God, I don't know if anyone understands this, but I hope you do. So I guess what I'm saying is that angle right there, that orange rotational angle, has the same x coordinate that this blue rotational angle has as its y coordinate. Oh man, maybe I've never tried to explain this in my life. I feel like I'm explaining this for the first time ever. I hope that made sense, guys. So, okay, great. I understand the geometry of it now. I get it. I get that the sine of 10 pi over 9 is a y value, and that y value is the length of this green stick. Now I'm being asked to find a new angle whose x coordinate is the length of this green stick. So I have to map over to here. So what's the geometry of the situation? I hope it's obvious to you that the geometry of the situation here is the rotational angle from x-axis to blue, meaning the reference angle of this given, is going to be the same rotational angle from the y-axis to the orange. Right? That would be the symmetry of the situation here, is as far as I've rotated away from the x, I would now need to rotate that far away from y. And I know what this number is. We just said it's the reference angle of the blue, which is 1 pi over 9. So if this red rotational angle is pi over 9, then I got some good news for you, because you also know what this lavender rotational angle is. That's pi over 2. So guess what the orange rotational angle is? It's pi over 2 plus an extra pi over 9. So I hope your addition of fraction skills are up for a challenge, but do you know how to add pi over 2 and pi over 9? I know I sure do. And I know the first step is finding a common denominator, that common denominator being 18. So I'll hit this with a 9 over 9, yielding 9 pi over 18. And I'll hit this with a 2 over 2, yielding a 2 pi over 18. And then I will rejoice in my final answer, which is 11 pi over 18. And so that angle is apparently the answer to what this expression is worth. That number right there. Oh, and it fell off the screen. Sorry, class. God forbid you can't see me adding fractions. But there you go. We had the pi over 2 plus the pi over 9, which we generated common denominator. So we had 9 pi over 18 and 2 pi over 18, which made 11 pi over 18. I am sure that you guys will have questions about this tomorrow. I hope you do. And like I said, I took this entire 10-point quiz yesterday. 10 questions, right? It took me, if I remember correctly, 3 minutes and 42 seconds, I think. And just to rub salt in Ms. Burke's wounds, it took her 4 minutes and 17 seconds. So Mr. F rules. But we did decide on giving you guys the princely sum of 15 minutes, which is this number times how much? Like 5-ish? Like 4 point something-ish? So don't tell me you can't finish. You can. And the moral of the story, of course, is 15 minutes. That means we have the first 30 minutes of class. You guys can hit me with questions. And remember, most of the questions on the quiz are these little meatballs from the beginning, right? Where I just go, ooh, which angle is this? And you guys go, 45, it's 45. And I mean negative 45. So I mean this one. So literally, yeah, negative pi over 4. That's not supposed to take very long. Even me pretending to screw it up and stuff, it took me like 4 seconds. So you'll be okay, I think. But, you know, hit me with questions if you have them. This might be my most useless video of all time, and if it is, I apologize, but I'll talk to you tomorrow. Goodbye.